your microphones for the time being. Yeah. Good afternoon and welcome to another talk in the climate policy series of the Devecha Center for Climate Change. Today's topic is developmental trajectories of nations based on equity, historic responsibility, and planetary boundaries. Or in plain language, it is what, I think most of you are familiar with the Human Development Index and what it means. And the question is that does the Human Development Index capture all the issues that we consider important? And so here you have a wonderful piece of interdisciplinary work that tries to extend the Human Development Index to take into account ecological footprint of nations as well. So let me introduce our speakers. They are Soumyajit Bhar and Chirag Dhara. Soumyajit and Chirag, I have known both of them in the past, when I was at ETRI. So Soumyajit is a PhD in economics from ETRI, the Ashoka Trust for Research in, I forget now, environment and ecology and the environment.
Ecology and the environment.
Yeah. And he's Soumyajit is now at assistant professor at Kriya University. Chirag Dhara is has a PhD in physics, and then he followed it up with another PhD in earth sciences and climate science. He works in atmospheric sciences. He's also an assistant professor at Kriya University. So without much ado, I think we should get started. So Soumyajit, you'll go first.
No, Chirag.
Chirag will go first. Right? So go ahead.
Thanks a lot, Sharval, and thanks for the invitation to speak here today. I'm looking forward to discussing this and hearing the thoughts from everyone here. So just let me know if you can see my screen.
Yeah.
It's all good?
It's fine.
Okay, great, thanks. All right, so without further ado, so just some context. There's been this intense focus on achieving net zero emissions, and arguably this has increased since the special report on 1.5 degrees back in 2018, and also in the context of COP26. Now, the attention paid to it is sort of so intense that there is a danger in some quarters of net zero being conflated with sustainability, which is not the case, of course. And the problem with doing such a thing would be that countries that have declared net zero targets would be identified as sustainable if that conflation were made. And that's not the case because, this has been very long known, of course. The Club of Rome was one of those famous reports more than 50 years ago, or 50 odd years ago, which warned of sharp declines in human well-being if our focus remains perpetual growth. So, in fact, when we look at certain human well-being indicators, they have indeed improved rapidly in recent decades for very many countries, for most developing countries. So here are four countries, including India, and you can see this upward trajectory. When we look at maternal mortality, for example, there's been a steady decline for the most part for most countries. And if we look at education, mean years of schooling, once again, you see this sort of steady rise in the last few decades across developing nations at different levels of development. On the other hand, the aggregate pressures of development have already led to global problems. Though the one, of course, is climate change with cumulative carbon dioxide emissions. And the other one is biodiversity loss, the other major one, where one index of sort of quantifying that is the Living Planet Index, which sort of suggests that in the last 40 odd years, 45 years, we've seen an average decline of about 60% in monitored wildlife populations. So climate change and biodiversity loss. In addition to that, there remain large disparities among nations and within nations. So this one here is among nations. So you see the overdeveloped countries of the global north right up there in Human Development Index, about zero point 0.9, 0.95. Whereas there's a whole range of countries in various states of sort of quote unquote development, which go up to from zero point 0.8 to the DRC at only about zero point 0.4, right? So the big question that arises is how can higher levels of development be achieved for the rest of the world while still maintaining climate and ecological integrity, remaining within the so-called planetary boundaries? So one can look at the question this way, and this is what we sort of do, is among all the nations of the world, can we identify aspirational models of development that can be sustainably scaled to the global population? And how might we go about doing that? What also Shilgal said right in the beginning is that the Human Development Index is a standard metric, but it is a misplaced one. And that's because it externalizes the environmental costs of development. We'll return to this point. But of course, this is very well known, long known. Now, the specific trigger for this work was a recent report by the UNDP, their Human Development Report of 2020, where they developed a metric which in fact sought to internalize the pressures of economic growth. Okay, and so they try to gauge the sustainability of countries, as it were. And this is their top list. So you see these overdeveloped countries of the global north appearing right on top of the list: Ireland, Switzerland, UK, Denmark, Sweden, and so on. Now, this automatically sort of rings some alarm bells because what also we know is that most of these, in fact, all of these countries that have achieved very high HDI, Human Development Index, have also breached what are called planetary boundaries, multiple planetary boundaries. So you can see them all basically over here. Yeah. And this is very well known. So there is this sort of very well known paper from 2018. Even before that, it was known, but this quantified it in certain ways. And so we kind of looked into the methodology of the UNDP's report, and we found that it was seriously flawed, unsurprising. But we sort of looked into exactly why that is and so on. So in fact, and I will of course return to this point because I'll discuss the methodology, one might argue that the UNDP's report, it fails at its task of identifying aspirational models of development, but more importantly, we would argue that it sets a dangerous precedent by offering essentially the illusion of an alternative. And that's basically what was the immediate trigger for our work, for this particular work, where we have tried to reformulate the UNDP's method, but basing it on strong sustainability criteria. And so I'm going to talk about this in sort of more detail to show you exactly where the problems lie before Sambhaji talks about the results of our new methodology reformulation. So firstly, the Human Development Index, very quickly. It's a composite of three indices. There's health, education, and what they often call standard of living, but basically that's just affluence. That's the GDP per capita. And the Human Development Index is simply the geometric mean of these three indices. And as is immediately obvious, there are no indicators for environmental pressures of development. Okay. Now, what does the UNDP's report do? They develop this new metric, and essentially they make a cost function, and they just sort of penalize the Human Development Index by that cost function. And what goes into that? So they basically consider climate pressures, and that's quantified by the carbon footprint. And then one might call it the ecological pressures, for which the proxy is the material footprint. Yeah. And so this new metric of the UNDP, which they call PHDI, is simply the HDI penalized by this environmental cost function, which is always less than 1. Yeah. And this cost function is simply two indices that they've constructed, one for climate pressures, one for ecological pressures, and they've just taken the average. But here's the problem, specifically about the UNDP's approach. How are these indices actually constructed? This is a form. So for any given country, whether it's the climate index or the ecological pressures index, you take the maximum, for example, if we talk about the climate index, you take the maximum, or rather, they take the maximum carbon footprint of any country in any year between 1990 and 2019 in those 30 years. Yep. And then they basically subtract the actual carbon footprint of the country in question. Okay, so essentially, and divide by maximum. So essentially, this is just a simple distance function. Okay, but distance measured with respect to the extremum value. Now, one immediately sees the problem here. The larger this maximum, even if this is large, but this is very large, you'll find that you don't penalize the HDI by very much. This const function becomes small because it's divided by this value. Yeah. So the consequence is something like this. I've just put down some numbers. Okay, so what we're looking at here are the carbon dioxide emissions footprint per capita for over here, and then the index that they construct the way they do. Then we have what's called the material footprint. That's basically the abiotic and biotic resources used by the country per capita. And then the ecological pressures index is constructed from here. Then the cost function is constructed, and that is used to penalize the HDI. And here's the percentage reduction in HDI that would result. This calculation is done for 4 countries. India is only at about 2 tons per capita of carbon dioxide emissions, roughly. And the material footprint is less than 5 tons per capita. Australia, you can see much higher on both scores, 17 and 43. Germany and Norway are not quite as much, but you can still see that they are about 4 times India's carbon emissions, and this would be 5 times, 7 times India's material footprint. Despite all that, Germany and Norway are only penalized by about 15 to 20%, despite these huge carbon emissions and material footprint per capita. Okay, and that's because of the way they've constructed these indices. It's a methodological problem that we're looking at here. So we've reformulated. And what we did was construct a metric which has a lot in common with the HDI and the UNDP metric, but we foregrounded 3 principles. One is equity, the other is historic responsibility for climate change, and the third one is the sort of emergent notion of planetary boundaries that sort of has been developed in the last 10 to 12 years. So in the metric, we deliberately preserve most of the mathematical formulation of the HDI and PHDI because the results that we get from a formulation, we want to make try and make an apples to apples comparison. Yeah, so that's why we keep the mathematical formulation, but we show essentially that foregrounding these principles changes the conclusions that we get from our metric compared to what you get from the UNDP metric. So how do we do this formulation? So the new metric, let's call it EHDR just for convenience sake. So we take the HDI, we have an environmental cost function of our own, and we take some function of that. I'll get to what that function is. Okay, and the environmental cost function is exactly the same one we saw before. It's the sum of the average of 2 indices, one for climate pressures, one for ecological pressures. And the whole sort of formulation lies in how this index is constructed, and that's what I'm getting at now. So firstly, the climate pressures index. So for each country in a given year, we calculate the cumulative global emissions according to the standards of living of that country. What I mean by that is, so suppose we take the year 2000 and we take India, okay? So we start with the year 1850. We use the per capita emissions for India in the year 1850 and multiply by the global population, yeah? Then we take the year 1851, we do the same thing, per capita emissions in that year multiplied by the global population in that year. We sum it up. That's the cumulative emissions for the whole world if it was living with the standards of living in the sense of carbon emissions of India or any other country of interest. We do this country by country. Yeah? And then we construct this simple ratio where we take this quantity, cumulative global emissions, and just divide it by the global emissions until the year 1990. And why is that? That simply comes from previous literature. where this is kind of chosen as the planetary boundary. This is the cumulative global emissions, yeah, in the year 1990. And that, in fact, turns out to be around 800 gigatons of cumulative emissions. So essentially, this is just a ratio of the quantity we compute divided by roughly 800 gigatons. And now our index is constructed from this, where we say that if this ratio is greater than 1, which is to say that it exceeds 800 gigatons, which is to say it exceeds the planetary boundary for climate pressure, we take the inverse. We just take the inverse because we want an index less than 1, between 0 and 1. Okay, and if it's not greater than 1, we just leave it as 1, which is to say if it's less than 1, we normalize it to 1. Okay, so effectively we get a quantity, an index, which is between 0 and 1, 1 being no exceedance of planetary boundary, and less than 1 being exceedance. Yeah, because it's a cost function, remember. So here's the concept of equity, the way we see it, where we sort of conceptualize it. We are taking the per capita emissions of a given country and then extending it to the global population. That's equitable carbon footprint of everyone on the planet according to the standards of living of that country. When I say standards of living, quote unquote. Yeah. So that's the notion of equity. We are taking the cumulative sum since pre-industrial times. So that's where historic responsibility comes in. This here is the planetary boundary for climate change. And this just comes from sort of the Rockstrom paper and Daniel O'Neill and so on. This here would, if we have this, where this ratio is greater than 1, that's essentially exceedance of planetary of the corresponding planetary boundary. And if it's 1 after it's normalized, it means that doesn't exceed the planetary boundary. So then we move on to the ecological index of ecological pressures. The way we construct this is that we take the global resource use for a given country in the year T. Okay, so essentially it's the total global resource use in year T at the standard of living of the country in question. So we simply take the per capita material footprint. The material footprint is the sum of abiotic and biotic resources used for the economy. We just take the material footprint for, say, India in the year 2000 multiplied by the global population in that year. Yeah, and we do this country by country as before. And now we take the ratio of that resource use, and this is kind of the planetary boundary. Again, this comes from previous literature by Daniel O'Neill and among others. And that's how we construct this ratio and the index as before. Yeah. So if this exceeds the planetary boundary, we take the inverse, otherwise it's 1. So planetary boundary. And here's, let's return. Now that we know the two indices, we take the environmental cost function as the average. And the new metric, unlike the PHDI, the UNDP's method, we do something slightly different, which is we take essentially the geometric mean of now 4 components. The initial 3 of the HDI, health, education, and affluence, and then this environmental cost function. But we are taking the geometric mean over all 4 because we want this to be equivalent in the sense to the other 3. Whereas the UNDP method, it simply sort of took the HDI and multiplied by the environmental cost function. But we also argue that that doesn't put them on equal standing. And that's the reason we kind of go with this. So just one table I'll show, that's the formalism. We put in the data and we compute how countries perform on this metric. And what we find is that the top performing countries on our metric is quite radically different from the analysis by the UNDP. So these are those countries where we have right on top Costa Rica, Panama, Albania, Sri Lanka, Peru, Georgia, Colombia, Algeria. Okay, so basically these are countries that have achieved a reasonably high standard of living in terms of their HDI, but without putting undue pressures on the planet. That's what we are capturing with this index. Yeah, so a picture which is radically different from what the UNDP proposes as the most sustainable countries. So with that, I'll hand off to Samajit. You can take over.
Thank you, Chirag. Yeah, let me share my screen. It's taking longer than usual. Sorry about that. Hello.
Yeah, we can hear you, Samajit, but can't see your screen.
Yes, I think my browser is creating some problem. Oh.
Would you like me to share and
Yeah,
just
I
let me
think
know?
that would be better, I guess. If
Okay.
unless, yeah.
Hold on. Let me do that. Yeah.
No, I think I don't know. Can you hear me clearly?
Yeah, I've shared my screen if you would like to.
Yeah, we can hear you. So
Okay.
Chirag's screen we can see. So go ahead, Swamiji.
Okay, good. So as you can go to the maps, we can see the two maps. Let me quickly go through with the results that already Chirag initially showed the first 10 countries. So we have done the analysis for 163
Sorry,
countries.
Chirag, your screen is showing loading. I don't know. Can
Oh,
you?
Oh, really?
Yeah,
That's
yeah.
surprising.
just allow me a moment. I will join back. Just allow me a moment.
Yeah,
Sorry
now
about.
it's
I'll just join back because then I can show my cursor. It's just I don't know. It's just my browser is just not working. I'll just join back. Sorry about that.
Sure.
Yeah. Thank you. Yes. I hope you can see my screen.
All good.
Yes. Okay. Great. Sorry about the technical glitch. So yes, so there are now two maps. Let me quickly take you through both the maps. So the first, the top one, actually shows. So as I was telling, we have actually done the calculation for 163 countries because of the data which was available, and now which is about 99% of the world GDP and about 99% of the world population it covers. So as you can see, the first map shows the values of EHDI, the actual values of EHDI, and the greener it is, better it is, higher EHDI values, and red it is showing a low EHDI values. So one big pattern that we can observe is that most of South America is quite green, so it generally performs quite high in terms of EHDI. Same applies to more or less South Asia, Southeast Asia as well. Parts of Africa is performing poorly, though we'll explain that because of they have a very low HDI to begin with. The stark thing to observe is US. It is not performing as good as it should, or it generally performs in terms of HDI. Australia, Western Europe, their performance are rather poor in terms of the EHDI values. Now coming to this, the bottom map actually shows the difference in rank. So the difference in rank a country has in its EHDI, subtracted from the rank it has in HDI, basically. Sorry, it's the opposite. The HDI rank versus the EHDI rank. So if US is red, that means it's almost minus 100. So it means that it has lost 100 rank. Like it has a very low HDI rank, somewhere around 1 to 20, whereas the EHDI rank is somewhere around 130 or so. So the difference is above 100, and it is negative That's how the difference is shown here. Whereas in case of India, it is generally an improvement in rank. So it has improved its rank compared to its rank in HDI when you compare it with the EHDI. Same thing applies with Southern America nations. And as you can see, as the point I was highlighting, most of these African countries which are red, they actually hold on to their ranks basically. So they were poor to begin with in HDI. They also remain poor because it is a cost function, as Chirag described. So if the HDI is already low, EHDI values are going to be low as well. So they are white. So there's no difference in rank, broadly speaking. Whereas the Western Europe, again, is almost not as red as Australia or US, but still it's quite red, and which showing that it has a huge difference or a huge drop in rank, basically. So the broad findings, just to quickly summarize, South and Central American nations perform the best. North America, Western Europe, Australia, Sub-Saharan Africa performs the worst, though Sub-Saharan Africa is an exception, as I've already highlighted. I don't know, I'm getting some noise from someone. If you don't mind, could you mute? Thank you. So global North and Middle Eastern nations observe a steep drop in ranking, like broadly the Western Europe and the US, as well as the Middle Eastern countries also show a huge drop. And the improvement happened in South America, East and South Asia, indicating human development has entailed low environmental pressure. So it has not shown much exceedance. So that's why whatever the HDI, their present HDI is, the EHDI value is actually higher than the HDI, and they have significantly improved in their ranking. So even if they have not managed to achieve high HDI values, they have managed to do it within a very less environmental exceedance, or not at all, no environmental exceedance, and that's why their performance in EHDI is much better compared to their performance in HDI, compared to the other HDI that the global North has. Now let us. So this is for 2019 that we show. However, we have done the calculations for since 1990 to 2019. So we have the data for 29 years. So that helps us see the trajectories, how for different countries, how the values of HDI and EHDI has evolved, which will provide us further insights. So let me first explain the panel. So as you can see, there are 20 countries we have listed here, and these are selected countries. They are not any specific group, which will be showing some specific group later. Now the EHDI, which is the blue line, which is ideally, and the HDI, the red line is corresponding to the HDI. It starts from 1990, goes till 2019. And the ideal scenario, the HDI should be higher than the EHDI should be higher than the HDI. And if they follow a parallel pattern, basically they remain parallel to each other, the EHDI being higher, that is the most ideal scenario that we are hoping for. The opposite is what we should not hope for, where there is a divergence pattern and the EHDI is falling, whereas the HDI is going up. So that means HDI is going up, human development is happening for that country at the cost of environmental exceedance, and that environmental exceedance is mounting with years, with as we go into future. So that is the problem that we have. So now, if I take you through the patterns, as you see, Armenia, which performs quite well in EHDI, we see the EHDI ranking. I mean, the EHDI value is higher than the HDI value, though there is a convergence happening. If there is a convergence happening, that means if we project it further, we will actually see EHDI actually falling down and the HDI maybe picking up. Whereas in case of Bhutan, though we don't have data before 2005 for Bhutan, we see a more or less a parallel pattern where the EHDI is higher than the HDI, and it is remaining more or less parallel. Although one can see that the HDI value is very low to begin with compared to Armenia. So like even in the year 2000, it is just about 0.7. And if we focus on Ireland for that matter, so Ireland is the diverging pattern, like the which I was studying, which is really alarming, because even though its HDI has mounted almost to close to 0.98 or like almost touching 1, the EHDI value is continuously falling, though the downward trajectory is not as steep as we will observe for like maybe United States or United Arab Emirates or Japan. However, still it has a downward trajectory. Even Norway, for that matter, if you see, it has a downward trajectory, and it's a clear divergence that is happening over the years. So basically, these countries are achieving high human development index at the cost of environmental excedence. It is not really managing to maintain any form of decoupling or any form of absolute decoupling, which will come in and discuss like in detail. A few interesting countries are Peru and Sri Lanka, Gabon to an extent, Ecuador, and Vietnam, and Tunisia. So these managing to maintain a parallel pattern where the EHDI is higher, especially for Sri Lanka, which is also managed to achieve very high HDI, almost reaching 0.8 in the year 2019. Whereas Ecuador, like where Ecuador also managing to achieve almost 0.8, but Gabon is much lower, or Peru also is slightly lower compared to Sri Lanka. So yeah, so this is the broad conclusions that we can draw from this select country. As we go to more specific groups, we will understand these patterns better. So this is for those countries which has performed the best 20 top 20 EHDI countries. The same logic holds. As you can see here, you will see more parallel pattern, right? The HDI might be slightly lower or higher depending on different countries. However, the parallel pattern is more or less which is constant. There are few exceptions, which is Cuba, Bosnia, and Georgia. But other than that, more or less all countries is trying. Though there is a slight decrease happening in the difference, but still it's more or less parallel. Broadly, you can say, which kind of shows that the countries which has managed to achieve high HDI are actually managing to do it within environmental limits, and it's not showing much exceedance, and that's why it's showing a higher EHDI value compared to its actual HDI. Going to, this is the G20 nation, Great 20 nations, and there, as you can expect, most of the countries shows this diverging pattern. There are few emerging countries, Brazil, India has India's performance quite exception and I think I would say the best in the lot, including the Indonesia. Though India's HDI is not that high, it is barely 0.65. In case of Indonesia, it is it has crossed 0.7 in the year 2019. Whereas for all the other countries, you see a diverging pattern of varying degree. For South Africa, for Russia, it's just like starting to diverge, whereas UAE and United Kingdom, USA, Germany, the diverging pattern is evident. Going to this is the best 20 HDI country. As I showed the top 20 EHDI countries, this is the best 20 HDI countries. And as Chirag was indicating, that all the countries which has come top on the list are going to have very high environmental impact, right? In the map, the map where different countries were listed. And this is precisely shown in here. Like, as you see, all the countries show a very large diverging pattern. Like, see for matter Singapore or Norway, their divergingness, that really diverge, and the values of HDI is almost touching 1, whereas the values of EHDI is almost touching 0. No, not 0 in this case. It's going 0.5 onwards, around 0.5. So that is something which is the difference in their ranks is huge, and actual difference in the absolute value is also huge for these countries. Okay, so now with this, I'll go to a different set of diagram. So now one thing we have understood, that different countries show a diverging pattern, or they show a parallel pattern depending on whether they are having environmental exceedance or not. But the question is, at what point generally this diverging pattern starts to emerge? At what value of HDI, I mean? So that is an interesting question which we try to answer through the next set of diagram, and that I'll go into it, because we know that as countries develop and go over a certain level of HDI, they tends to show a diverging pattern where EHDI values goes down below the HDI values and then it starts diverging. So I'll explain the diagram, what we have done here. So this is again the top 20 EHDI countries that we have shown. And we have just plotted the HDI. The x-axis here is the actual HDI value. And the y-axis here is the actual EHDI value. And this dotted line basically shows if there was no environmental exceedance. If as Chirag has discussed, the environmental exceedance, if there is no environmental exceedance, then the environmental cost function will have a value of 1, right? So if that environmental cost function would have had a value of 1, then this is the trajectory a country will follow as it changes its HDI over the year 1990 to 2019. And now we have plotted their actual HDI and the EHDI values, and we have shown that line, the red line, is showing their actual HDI values in that year and corresponding EHDI values in that year. And as you see, for countries like Albania, it tightly follows that same pattern. So that shows that it hasn't gone beyond the environmental cost function basically had 1. So it has not had any environmental exceedance so far till the year 2019. Same thing applies to Algeria. However, Armenia, it is interesting that you can see a slight divergence happening once it crosses the HDI value of 0.75. So this is, I think, one of the main key findings that we'll kind of reiterate through the diagrams we'll be showing, that once most of the countries crosses 0.75 values of their HDI, they start diverging. Same thing applies to Georgia. Same thing applies to Thailand. Even Moldova also showing a similar pattern. But yeah, many of the countries still are following the dotted line tightly, and it is not showing much divergence. Sri Lanka, for that matter. Some of them have actually crossed 0.75. It is not that all of them are haven't crossed. Like the example is Sri Lanka, Panama, and to an extent, Peru. They have crossed 0.75, but they're not very far away from 0.75. They are just about 0.75, not even 0.8, around that range. And they haven't shown any exceedance so far. Now, if we plot the same diagrams for G20 countries, we'll see a very different pattern as we expect. Like, if you see for Brazil, it is again at the value of 0.75, it is showing a divergent pattern. Like maybe slightly before 0.75, it is actually maybe 0.71, 72 onwards, it is showing a diverging pattern. However, like same thing applies to Argentina. Broadly around 0.75, it starts diverging. Same thing applies to China. Around 0.75, it starts diverging. Same thing applies to Mexico. However, for other countries, Turkey also the same pattern. For other countries, you see like a country like Russia, it is below the optimum, so it has some environmental exceedance. However, it manages to hold on to that same trajectory, right? It is almost parallel to that dotted line. So that means whatever the environmental exceedance had been, it maintained that same environmental exceedance. The environmental exceedance hasn't mounted with years. However, in case of Italy, in case of Japan, it is showing almost a 90-degree trajectory to that dotted line, indicating that the environmental, there is not only environmental exceedance with as it came till 2019, the environmental exceedance kept mounting, and that's the reason why it had such a pattern of like almost perpendicular to the dotted line. And as you can see for Korea, it is again having a similar pattern. United Kingdom is slightly better, I would say, because it is not parallel, but it's not perpendicular, somewhat horizontal to the x-axis, remaining horizontal. US also showing a almost perpendicular pattern to the dotted line, showing that it is the deterioration is mounting as we come to 2019, basically. Going to 20 best HDI countries, again the same pattern, and interestingly enough, if you kind of try to kind of trace backwards, because from the year 1990, it has countries like Finland has already crossed HDI of 0.75. It was already around 0.8 or something. But if you trace back, you can easily understand that around 0.75 is what it might have a pattern which might correspond back to the dotted line. So all this thing divergence not only showing that it has diverged, but it is also, if you trace back, it will go to around that 0.75 mark where it must have diverged, and then it started diverging further and further as they went into higher and higher HDI values over the years. And the similar pattern persists here as well. Most of the countries shows almost a perpendicular or like quite steep downward trajectory, whereas countries like Germany is comparatively better in compared to the other countries on the lot. It manages to maintain a almost horizontal to x-axis or almost parallel to the dotted line kind of a pattern. So what are the broad conclusions that we can draw from here? So the best EHDI countries that we have discussed, it seemed, at least from our result, the development model that they have demonstrated can be extended globally, because even if we extend that globally, and it will remain the whole world's environmental footprint, climate pressures and ecological pressure would have remained within the planetary boundary. And G20 nations, though there has been a lot of discussions in this period 1990 to 2019 of decoupling, of improving efficiency so that the GDP can be decoupled. There is no sign of absolute decoupling happening. That's clearly showed by the diverging pattern. Like the EHDI values ideally should, even if they start with a lower EHDI value, at least the EHDI should be parallel to the HDI pattern, right, or the curve, right? Even if it's lower, the EHDI value could be lower than the HDI value, absolute value, but it should follow the same pattern. It should have been parallel. Then someone would have argued that, okay, there is some form of absolute decoupling happening, or there has to be some form of convergence happening. Then we could have concluded that there is some form of decoupling happening. However, that is not the case. Rather, the pattern is rather more diverging. So then definitely there is no decoupling happening. Absolute resource decoupling seems impossible, as in our study we show that we have used ecological pressure material footprint in our calculations, and that definitely showed that the overall performance of the countries, there is no decoupling, as it's reported in Quebec and as well as Dhara and Singh's work recently. And the top 10 EHDI countries, one of the patterns to observe is that all of these countries are medium income countries. They generally have small land areas, low population size, and their HDI values are generally less than 0.85. So they are not very high HDI value countries. They're about that moderate, around that 0.758, 82, around that range. They're all belonging. But one of the important point is that they're medium income countries and they have a very small land area. So some might argue that maybe that might be the reason why the performance, the kind of performance that they have, could be that more research is required for us to make any conclusions in that. However, the finding that we have, that all of these countries have about a $20,000 per capita yearly income, around that, all were well within $20,000, which is the income limit that Hickel has used in his work on sustainable development while he developed Sustainable Development Index. Though he used it, or they used it as an arbitrary limit, our work kind of confirms that even if we don't take that limit, the countries which perform the best in terms of their sustainable development or in general, like, because Hickel also has used these two indices, like the climate pressures and the ecological pressures, that we come to that same number or similar number without not taking that arbitrary limit. And that we feel is kind of speaks, like it's kind of correspond well with the literature, as well as it makes our work more generalizable, because we are not using any arbitrary income limit. We are coming to that limit through taking the assumptions that we have taken in the beginning. And environmental accidents happen around 0.75 HDI, which I have already highlighted. This is also an important point. So as we go above 0.75, we tend to have more and more environmental impact showing up for most of the countries. Very few are the exceptions. So now, as we have understood the EHDI and the HDI value, it is important to deconstruct the EHDI and understand each of the environmental pressures separately, the climate pressures and the ecological pressures. So now, in this pattern, we are plotting the C index, the blue line, which is correspond to the climate pressures, and the red line is the M index, or correspond to the material footprint, or correspond to the ecological pressures, right? And as I think we have discussed in the methodology, if it is 1, if the value of that index is 1, then it's the best case scenario. There is no environmental exceedance. And once it starts falling from 1, and as it goes towards 0, it is bad. Like there is more and more environmental exceedance happening, right? So as you can see in this graph, this is the dotted line shows 2019. So we have done, this is the actual data we have for these countries. And then we have done a simple projection based on the last 10-year performance of that country and the projected population data that we have gathered for those countries. We have managed to make a very simple projection how it's going to be in the future till 2050. So these curves start from 1990 to 2050. And as you can see, this is for the select countries that we have begun with. And as you can see, although the countries like Armenia, Bhutan, they follow up like almost most of their environmental pressures remain 1 till present, and in the foreseeable, in the immediate future, eventually they start to have a downward trajectory into the future, and they show some form of environmental exceedance happening. Cuba, in that case, they are already started exceeding. The interesting pattern is here is Sri Lanka. Sri Lanka doesn't show any environmental exceedance till the year 2050. This is, I think, the exception. India also follows the same lot, though it shows a very little climate index, like climate pressure in exceedance in the last 5 years or so. However, except India and Sri Lanka, all other countries are basically showing environmental exceedance in different time, in the either in the present or in the immediate future. Going to the best EHDI countries, here we have the same thing. The broad patterns remains that the best EHDI countries also show environmental exceedance, even if they have not had issues so far. They actually show environmental exceedance into the future. Same thing applies to the G20 countries. The environmental exceedance are already present, and they worsen into the future as they go. And in case of India and Indonesia, the environmental exceedance is not there. So some of the broad observation that in the environmental pressure index or environmental cost function, both ecological pressure and climate pressure has contributed substantially, and not all. It is not like one of them is dominating the other. Like it's a kind of a mix between both the pressures have worked like almost equivalently, and not all top EHDI countries are going to remain within planetary boundaries in the near future, which I kind of broadly summarized. And G20 country and the best HDI country do not show any improving trend. We know they are showing exceedance, but whether there is any improving trend or not is the question. But there is hardly any improving trend to be observed. So we'll quickly summarize the broad results that we have had. So we have assessed the scalability of development trajectories of countries to the global population in the context of equity, planetary boundaries, and also taking a historic responsibility. And this is we see the way we have formulated the index. There are no such attempt has been made in this way, which takes all these 3 principles and try to provide an index which can summarize the human development in this manner. And we have foregrounded that Costa Rica and Sri Lanka are the best 2 available models of sustainable development, and this is one of the major contribution of this work. And whether these trajectories can be indeed be scaled globally or not is a larger question that we have to answer. As we have already highlighted that there are certain patterns that applies to this country which performs better in EHDI. However, we need to understand what makes such performance happens, we need to understand the policies and all that, which we intend to do in our future work. Yeah, with this, I'll stop share and I'll hand it over to Chirag to take us through the limitations. Chirag.
Okay. Actually, you could have just continued sharing, but
Okay,
I can well tell.
I can share. Do you want me?
Yeah, might as well.
Sure. Go ahead.
Yeah. Thanks. So I'm just going to take a few minutes to discuss the limitations, some of the limitations. Obviously, this is there are many sort of first order approximations and so on we've done. So some major limitations as we see them. So firstly, the material footprint that we use as a proxy for ecological pressures, it is this aggregation of biotic and abiotic resources that are used to power the economy. So for example, so specifically the way the material footprint is defined is the sum of the biomass, fossil fuels, uh, mineral resources, and metal ores that are used. Okay, the sum, just the sort of unweighted sum of all of these is called the material footprint. By the very nature of its definition, it does not distinguish between the relative abundances or impacts of these different components that constitute it. Right. So, for example, lithium and bauxite would be and wood would all be part of the definition of the material footprint, although some may be available in greater quantities than others, or when they're disposed, some of them might be more toxic than others. So the material footprint would not be able to distinguish any of these. Um, on the other hand, its merit is that it can detect cases of problem shifting. And by that, what we mean is imagine that we make one sector of the economy more efficient, which is to say less resource intensive. But because of that, there's another sector of the economy that becomes more resource intensive. Then the material footprint will detect that because it's a sum of all of them. Okay, one example is substituting electric vehicles for fossil fueled cars. So instead of using fossil fuels, we end up using more lithium and cobalt and so on. Yeah, so it's a case of problem shifting. Could we go on, Swamiji? Yeah. The other is that the quantitative choices of the planetary boundary that we chose, if you remember, the cumulative carbon emissions that we chose was 800 gigatons after the year 1990. That was chosen as the planetary boundary. And for the material footprint, it was chosen as 50 gigatons a year. Yeah. So this quantitative choice can be contested, although it comes from previous literature and so on. So the question then arises, if we were to change that, so let's say future studies, they ended up showing that the planetary boundary was slightly different. Would it change our conclusion significantly? So we tested that through through sensitivity analyses, and we ended up finding, and we haven't shown it here. We found that for most countries, the rankings don't change significantly. They do change, So we basically just loosened the planetary boundary or tightened it in both cases, climate and ecological pressures. And for a very few countries, the rankings changed by 20 places or something. But for most countries, it was in the order of 4, maybe 5 places. We can go on. Now, one major issue, and this, we have to thank Shorpal for also flagging this to us, is that we've done something slightly different with the two indices that we've used. The material footprint is formulated as a flow index, if you see the first point, which is to say that we are taking gigatons per year, whereas the carbon footprint is taken as a stock index. So the cumulative emissions up to 1990, which is just in gigatons because it's cumulative. Okay, but one thing is clear that we certainly don't have, perpetually 50 gigatons of materials, physical resources every year, endlessly, perpetually. So, of course, the material footprint must also, in principle, be formulated as a stock index, given that they are non-renewable for the most part. So this is something we still are yet to really incorporate in this formalism. Maybe we need to take an absolute amount of some sort and then measure the use every year against that, or a cumulative sum against that as a boundary. Maybe the boundary itself, we keep it as gigatons per year, but we take an asymptotically decreasing function or something of the sort. So there may be different ways to think about it. And in fact, we would appreciate your views, those of you that have worked on this before. Maybe you have thoughts on this. Would be very happy to hear from you on what you think. And I don't know if, yeah, oh yes. So ongoing work. Um, so there are different sort of lines of work that we have available to us, and two of them we want to discuss here. Firstly, for those countries where we find that the environmental pressures, climate and ecological, are increasing, why is that happening? Climate, of course, it's carbon dioxide emissions, but the ecological pressures for which the proxy is the material footprint, that can be disaggregated into various components, which tells us something about the sectors of the economy from which the pressures are coming. And so an analysis of this disaggregated data tells us why environmental or ecological biophysical limits are being transgressed and which sectors of the economy. Because if we understand that, we also sort of get a handle on what sectors of the economy require attention in terms of making them more efficient or making them less resource intensive. Secondly, this is something that's very much ongoing. The countries that we have identified as the most promising countries, which is firstly Costa Rica and Sri Lanka, and then there are others, Georgia, Albania, Armenia, and so on. We are trying to get policy practitioners and policy researchers from some of these countries together and discuss if there are deliberate environmental and economic policies that these countries have followed, which have allowed their economies to, or rather their sort of quote unquote human development to rise without undue planetary pressures. So, in fact, we've already identified um, two environmental lawyers, one from Costa Rica, one from Ecuador, and a policy researcher of sustainable development from Sri Lanka. And we are having this sort of, we are trying to build this collaboration. We also want to get a few more countries, but so far, these are the three that we've got. And the idea is to discuss if we can identify scalable policies that could be extended to other parts of the world, particularly the global south. So, in a way, one could think of it as a global south vision of development, because it's very clear that the global north vision will not work. They're overdeveloped economies, not developed economies. So, that's the attempt. And with that, we would like to thank you and open up for questions.
Hello. Thank you, Soumyajit and Chirag, for a very interesting talk. And I have to say that we are in some sense in a world where every year, I think a dozen new indices are being invented. And so it is important to have the right kind of index that, in some sense, highlights issues that are really important. And your EHDR actually does a very good job of that. It highlights the difference between reaching human well-being and looking at the impacts of that on both ecological and emissions related impacts. So I will actually point you to questions that are both similar in a way. So this is in the chat. If you open the chat, you will find that both questions are regarding the impact of population and especially population growth in other countries on the index that you have crafted. So if you can go ahead and answer that question.
Chirag, you want to go? Chirag?
You can go ahead.
Okay.
I can add on.
Sure. Yeah, I think that's a very valid question, and honestly speaking, like we have actually anticipated the question in my paper. We have actually anticipated that, and we have done a further analysis to show whether that makes a difference. So the point is this: that yes, we haven't factored in any other way that a country which is a high-income country, it takes the burden of population growth happening elsewhere, because the global population is taken as it is, right? So now the assumption from where these questions are coming, at least what we understand, is that as we see a country is growing, generally their rate of population growth tends to plateau, or it becomes even negative, as we see for many rich countries. So if I share my screen and I just quickly, we have actually the supplementary slides to just show you the results that we got. So I'll just allow me a moment. Yeah. So what have we done? So we have supplementary slides. So this is what we have done the analysis for a counterfactual world. So what we have assumed is that, so we are, instead of putting the actual world population on any country, we assume that since 1850, because we have the data since 1850 and all the calculations for the material footprint, it doesn't apply, but for carbon climate pressures we have used from 1850, we have considered that if the world population beginning in 1850 would have increased in the rate in which the concerned country's population have increased. So just to give a simple example, so Albania, suppose, showed a 5% growth in population from 1850 to 1851. So we have started with a counterfactual population for Albania. If the world the world population would have grown like Albania, what would have happened? And we have started with 1850, and then we have keep applying the yearly year-to-year population growth that the actual country has shown over since 1850 to till 2019, and we have reached different world population for different countries, right? If the world followed that country's population growth pattern, so that we thought would be much more equitable and much more just to those countries, and we wanted to see for ourselves whether that makes a huge difference or not to our calculations. No, whatever we have done, rest all remains the same, only the world population changes. Now each country will lead to a different world population, and surprisingly enough, you will be surprised to know that there has been some exorbitant high population numbers have come up. Like countries like India would have taken, if the world followed the population growth pattern of India, we would have had about 9 billion in 2019, the population, which was about 7.2 billion, right? Whereas for most of the Western European countries, we see the population is below 7 billion on the actual, but it will be about 4 to 5, around 3, 4, 5, 6 billion was. But for US, for Canada, because they have shown huge population growth, huge rise in population growth happening in the 1940s, 50s, 60s, their population, like their counterfactual population, would go up to 30, 40 billion, and which was, we also was initially quite surprised, but we followed a logic and we just did the calculations, and then based on that we have used the same calculation, same results. Now as you see, for Albania the same pattern holds, but for Costa Rica we see a very different pattern. Like there is a very divergent pattern which we observe, and for some of the countries it follows the similar pattern. For most of the countries, actually, to our surprise, honestly, that it actually follows a very similar pattern. However, there are examples of like Thailand, Ecuador, Costa Rica, even Cuba for that matter. The EHDR actually comes down, but still it is not showing as divergent pattern as it was for most of the developed countries. In a developed country scenario, we still hold the same pattern for Australia, Australia, United Kingdom, United States of America. They still have that divergent pattern, not as divergent as it was initially. However, there are, France, it doesn't show much divergence. It actually goes almost hand in hand, but still it is. So the overall conclusion that we draw from here is that it does make a difference, but still it is not completely overturning the results that we got in our earlier result. It does make a significant change, but still our broad conclusions that we made there can be, we can still kind of hold in this scenario as well. So yeah, so this is just, we wanted to quickly share as this question came up. Yeah, Chirag, you wanted to add something to that?
No, well, just a short sort of comment, I guess. One thing I would add is Sri Lanka once again really stands out over there because even in the second analysis, Sri Lanka, much like the previous analysis, um, yeah, the original sort of EHDI metric, it shows the exact same behavior on both, whether you take the original calculation or this counterfactual calculation. And that really stands out, a very sort of interesting case study. Now, the other thing, of course, is population. Population enters the calculation through the way we construct our index. If you remember, we took the per capita and multiplied it by the global population. So population growth enters the calculation at that. Having said that, to first order, the fertility rates of a country are often tied to its relative affluence. Yeah. And one could argue from a sociological perspective that affluence, there's been this tremendous, vast transfer of affluence from the colonized world to the colonizing world. Yeah. So when we talk about population growth in certain countries, without that context, it can look very it sort of ignores the context in which the growth is happening. And also that growth is often among people whose consumption otherwise is extremely low in sort of what one would call lowly developed countries or developing countries and so on. So that's something to bear in mind, aside from all the analysis that Samajit showed. So that's kind of what I wanted to contribute.
So I see some raised hands, but before I hand over to people with questions, I would like to point out one issue with your counterfactual. So I think it is quite sensitive to where you start your counterfactual, whether it's 1850 or 1950 or some other year. And your counterfactual, the way it is designed, it strongly penalizes countries that have seen significant immigration. For example, I've looked at your numbers. You take Qatar, Singapore, even the US, Australia, significant immigration, so their population will definitely rise faster than usual. And it benefits countries that have, over this huge period, either low growth or low relative to the world. Now, if you take India, for example, India you would assume is a very high growth country. But if you actually look at India's population growth between 1850 and 1930, very low growth country actually. We had so many famines, plagues, the Spanish flu and so on. There were decades where we didn't grow at all. After that, the growth is a lot. True. You find France surprising? France is surprising because France has traditionally always been a low fertility growth country, if you compare it to some other. So, and then that's why you see that after you do your counterfactual, you probably find that some Eastern European countries seem to be doing very well, right? It's because they both have low fertility growth now, as well as they probably suffered tremendous population loss during the wars. So I think I would suggest that you should try to in this counterfactual go a little beyond this simple formula. Try to maybe move the start year a bit, or try to take into account immigration, which makes a big difference. It will make a big difference for the Middle Eastern countries, for example.
True.
So that's the only thing I would like to suggest.
Excellent. Terrific, Shoaib. Thanks so much. Very nuanced comments there.
Yes.
Yeah. So I will hand over to, okay, there were two hands raised. First, I think it was Anupama. So Anupama, please go ahead and ask a question.
Yes. Thank you so much. Can you hear me?
Yeah.
Yeah. Thank you so much, both of you. That was very interesting. Because like Shoaib mentioned, you come across these kind of different indices every now and then, and I hadn't really come across something similar before. But one I have come across before is an HDR that's adjusted to inequality. And I was wondering if, if you've thought of, sort of incorporating that into this as well, because that also is quite an important parameter, in my opinion, when you look at development overall. And secondly, another question I had was, I guess this is sort of abstract, but where do you sort of see inputs from these kind of indices going? Like, do you see or do you hope to see like a shift in, this like the overall sort of understanding, or like the UN's understanding in this instance of development? Like, is that a change that you would like to sort of see in the way that we compare countries on the basis of development? I'm sorry, that's a very vague question to ask, but I hope you understand what I mean.
Yeah, Chirag, go ahead.
Terrific questions. Do you want to take the first question, Samajit?
Yes, I can.
Go with the
I can.
second, because
Yeah.
we've actually worked on that.
Yes. So Anupama, yeah, we don't have the supplementary slides prepared for that, but we did actually take the IHDI, that's called Inequality Adjusted Human Development Index. So unfortunately, the IHDI is not provided for this many years, since 1990 to 2019. It is only provided, at least that's what we could figure out. It's only provided, I think, for 2018, if I remember correctly. And it is not provided for those many countries. It was provided for less countries, about 123 countries. But what we did is that we just used that IHDI value instead of the HDI value, and we created a EIHDI value, which is basically Environmental Adjusted Inequality Adjusted Human Development Index. And we do have the results with us, though we don't have it to show it right away to you. But we don't have any trajectory or anything. But I see that why not we can just apply this to IHDI values if we see more trajectories of IHDI values, and we can just apply, and in that case it will take care of both the challenges, like inequality as well as the environmental pressure. So yeah, I think I think it's a very valid question, and we see the point you made. Thank you.
Thanks, Samajit. So as to the second question, if I understand it correctly, and please sort of feel free to jump in again if I'm taking off on a tangent. I would answer this question this way, which is we constructed this metric and we identified certain countries of interest based on that. We are not really wedded to the metric itself. We see it as a way of identifying certain countries that appear promising in terms of their developmental trajectory being scalable to the global population. Now, the future work that I described right towards the end, the outlook, as I sort of mentioned, we have identified these policy practitioners and researchers in these countries of interest. So far, 3. And we are hoping for more, but we don't know anyone personally, so it's also hard to sort of get them to respond to us. And we are wanting to do this analysis. In fact, we are having our first meeting on the weekend. Do this analysis of looking at their environmental policies and seeing which of those might be scalable to other countries in the global south. Many of them will not. Some of these countries are very resource endowed, and there's nothing one can do about that. Costa Rica, for example, they have geothermal, they have a lot of solar, wind also. So that can't be scaled. But there are other policies that Costa Rica has adopted in terms of clear cutting, or rather not. And other such policies. So far, I don't know very much because I was only sort of got a sort of flavor for it during one of my discussions with Carolina, who's an environmental lawyer in Costa Rica. But then the other person, Viviana from Ecuador, she told me about the rights of nature in Ecuador. And in fact, some of you may have read that recently, I think it was in Ecuador, where they won a case against a mining company. They got a mining project stopped, arguing that it violated the rights of nature in that region, not the rights of the people living on that land, but the rights of nature directly. So it's not just a conceptual thing which has been put down in the constitution or whatever. They're actually being able to use it. So some of these kind of policies, would it even be replicable in that same country under different circumstances? Would it be replicable elsewhere? Very complex questions, to be sure. But at least there are certain ideas and a certain vision for what could be possible. So that's how I would answer that question. But please ask the question again if you feel you meant something else and I answered something totally different.
No. Thank you very much. That's quite interesting. And I think with that sort of an aim in mind, it makes sense to maybe try not to, add a lot of other things adjusted to your HDI at the moment, perhaps later. Yeah. Thank you.
Right. Thank you.
Karthik, please go ahead and ask your question.
Hi. Soumyajit, so the first question, the earlier question was also mine. But I wanted to ask about this idea of problem shifting that Chirag you mentioned. So I'm just curious. I didn't follow. Does that include? So, for instance, if an iPhone is manufactured in China and then consumed or used in um, Ireland, does all the material costs of producing the iPhone get attributed to Ireland or China under your current analysis? And I think that ties into my second question, which is about, I mean, I think it's precisely about this question of scalability, right? Because Ecuador, Costa Rica, and even Sri Lanka to some extent, these are countries which have, for geographical reasons, they're able to derive revenue from non-tangible services, tourism, for instance, right? Now, that's a privilege that some countries have and other countries don't have. And you can't, the entire world cannot survive on tourism. So um, the question of scalability becomes quite.
May I, Samiji?
Yeah, please.
Yeah, great questions, Karthik. Very much so. And just on the second question, my memory tends to be very bad. So let me just go with the second question, since that's more immediate on my mind. That's precisely why we are not wedded to the notion of EHDI. We are using it, we formulated it as a mathematical formalism, then we put the data and got some of these results. But the idea is not to read too much into it, so much as use it as a vehicle to identify these countries and then see if we can learn something from there. Now, if it turns out that many of these countries, they've basically, they're living off their own their own natural resources because they are highly endowed, as is the case with some of these countries, or of intangibles, as you said, like tourism. Well, those are not scalable. There's really nothing to be done about that. But are there scalable policies? Are there scalable? So that's the identification we want to try and make. If it's not, then that's just bad news. If there is, then let's hope we can identify those. What happens next is another matter. But so it's a great question. We hope we can find some answers at least. The
Yeah.
first question, the problem shifting. Sorry, Samjit, please, if you want to add.
I can. Yeah, so I think what Karthik was asking, at least what I understood, is that whether so there is a production-based CO2 emission and there is consumption-based CO2 emissions, right? And there has been a lot of discussions, and recently we have redone the calculation. So initially we have went with the production-based CO2 emission, which is basically if the product has been produced in China, then the value will be assigned to Chinese people, like, or Chinese folks, right? So now the problem why you went with production is that we don't have values of consumption-based CO2 emissions since 1850. We have since 1990. But then we had discussion with Ashish Kothari, and Ashish was not happy. He was like, no, you should be using consumption-based and you cannot use production-based. So then we made that assumption saying that we have wherever the data is available, we have used the consumption-based CO2 emission. Wherever it is not available, we have gone back to the production-based and made the assumption that if that data for consumption-based is not available, then both are same for that country, for that year. And then we have redone the calculation. There has been some minor changes in the ranking, not significant, obviously. And we have, like, the results that we have showed here are the redone calculation, which we have a slightly older version. So now it actually captures the consumption-based one for carbon. For material, it is only the one value which is given. It is not. Yeah. So Chirag, you wanted to share about the material?
Yeah. So Karthik, very specifically about the material footprint, there are two concepts. One's called the domestic material extraction, or something called DMC, I think, domestic material consumption. Okay, and the other one is what's called the material footprint. The domestic material consumption, it does take trade into account, meaning it's assembled somewhere, but it's being used elsewhere. So who do you attribute it to? So the DMC, I hope that's yeah, I think it's the DMC. It actually takes that trade into account. But what the material footprint does, it takes the trade into account. It also takes wastage into account. Yeah, because for example, if we look at a car that weighs a ton, yeah, it's not just it comprises glass, plastics, metal, rubber, whatever. Yeah, 1 ton of all of that. But more of the raw materials than just 1 ton has gone into it because there's always wastage in the production line. It takes even the wastage into account. And that's what the material footprint has sort of been. It's quite an elaborate calculation, but those have been made, and there have been some. There's been 1 or 2 very important papers back in 2015, which kind of showed how the input-output model, which can do this. As to the problem shifting, actually, what I was trying to express is also perhaps something slightly different, not just the idea that it's produced somewhere and used somewhere. But suppose we take fossil fueled power cars, they typically don't have as many electronics as a electric car. Yeah. So when we go, if we substitute simply a 1 ton fossil fueled car to a 1 ton electric car, the kind of materials that are used for this car and that car are different. And the kind of rare earths that are required for the electric car are so there's going to be a big spike. There already is. For example, the batteries, the lithium, cobalt, and so on. There are substitutions that happen instead of cobalt or instead of cobalt from DRC elsewhere, or instead of cobalt, some other element, but it's always some element. Yeah. So it kind of shifts the problem from the use of fossil fuels to the use of some other physical resource, which also comes from mining, which also has ecological impacts. And when it reaches end of life, unless it's effectively recycled, you get a lot of pollution, air, water, soil pollution, which again, ecological impact. So that's the problem shifting issue I was expressing.
Well, any other questions? Otherwise, I will ask another question. Um, so, if you have actually identified a set of countries that seem to be exemplars, right? And you also identified a particular HDI where you think that, what do you call it? Actually, it's an inflection point, right? Now, by and large, if I put my common sense hat on, I would say that, well, it's very likely that if I take the 3 different components of HDI, it's very likely that education and health by that time would, in some sense, have saturated into a narrow band. Right? I wouldn't be wrong to claim that. So almost all of the difference is actually coming from the GDP or the income part of the HDI. And as we know, this income is, at least globally, if you see, with the exception of, say, Costa Rica or Brazil, is very strongly correlated to both emissions as well as material footprint. Right? So, and you could use this, just carry the analysis a little forward, and then identify that range of income where this inflection point happens. So, in some sense, that is well, once you get to this income range, maybe it is, I don't know, $10,000 to $15,000 or $5,000 to $10,000, something like that. You can, by that time, if with the right policies, and of course, it is important to have the right policies in the country, not too much inequality, etc., etc. So, assuming that is there, you have a decent enough life at this income. Now, one could use this analysis to say, well, this is by and large, most developing countries might want to, or the whole world might want to converge to this income band. This is where Somijit's degrowth, for example, could come in, right? So that is one way of looking at this analysis. So do you want to elaborate on that and say that, well, this is but this of course assumes that our current material consumption and carbon emissions would continue. It needn't. We might have drastic technological change in this decade, and both the emissions as well as the materials footprint might go down. On the other hand, the emissions footprint might go down, but the materials footprint might go up. But nonetheless, it's useful to actually take this analysis forward and say, well, if this income range is the desirable income range for the whole world, how do you, what would you say about, what would you say to the world's policymakers about that?
Chirag? Yeah, so I think, very insightful, comment and question, Shoibal. Yeah, I think you're right. Like this is a new line of inquiry that we can do, and as well, I was telling, like we have kind of examined that all the top 20 EHDR countries are in that income range, about $15,000, $20,000. So you are in a way almost saying that, can we like create a cap on income, and like, you know, how that is going to eventually, you know, translate into and maybe we can even see the when those countries which are currently you know, showing a lot of environmental, like the global north basically, when they were at that income level of whatever the $20,000 income range, what was their environmental impact back then, like in the year, maybe it has to be beyond 1990 for most of the countries, unfortunately, but at least if we can have some amount of understanding on that line also, that can actually also put an like shed some light on this question. But yeah, I think broadly I agree with it that this is an area which needs to be explained, and obviously we cannot predict what is going to happen in the future in terms of technological innovations. That is, I think, anyway, we cannot count that in our calculations, but I think with taking this income limit, we can actually do a certain calculation to see whether the whole world remains within a sustainability limit or not. Yeah, I think that's an important point. Chirag, you wanted to add something?
Yeah, absolutely. So, Shobal, what you're suggesting is basically like a sufficiency clause. And in fact, there is this paper, a very interesting paper by Jason Hickel called, and he's come up with another metric, the Sustainable Development Index, SDI. It's a whole family, right? And he's done just that. He's imposed this sustainability, this sufficiency constraint of 20,000 US dollars, exactly what he just said. And we have not done that. We've not put any constraint of that sort because it's an empirical constraint. Of course, one can. There are good reasons to say somewhere in the 10 to 20,000 range for empirical reasons, but still, the choice is something that one has to make, and that becomes, there's some subjectivity there. So we chose not to do that, and we chose to sort of foreground these three principles: equity, historic responsibility, planetary boundaries. So there is us with our results, and there is the Sustainable Development Index by Hickel, where he's actually used an empirical sufficiency constraint. What's really remarkable is that our results are virtually identical, although our methods are different. Yeah. So there are clearly very deep synergies, and in a way, one can perhaps argue that the principles that we foreground essentially end up meaning a sufficiency constraint. It's a dangerous argument. One needs to think that through. But at least from the way the results, the top 20, top 50 countries are, there's some change. There's some difference in rankings. But when you look at the top 50, they are essentially the same as us, and the top 20 are basically the same as us, with almost the same rankings. So there are deep synergies there. The second part about disruptive changes in technology. So the way we did our projections, right? So any disruptive changes we won't be able to account for it. So then what we did, we just took the trends in these pressures in the last 10 years and we extended it forward. And the way we sort of justify it is the precautionary principle. Let's not assume that there's going to be this dramatic change in technology which saves the day for us. Let's assume that the trends continue. And then what would happen in that case? Of course, if there is a disruptive change, good for us. But let's not proceed under the assumption that that'll happen and overestimate how well we are going to perform in the future. So that's kind of the way we look at the problem.
Yeah. Thank you very much. That was I would say, a wonderful talk, and you've given, I think, our audience a lot of things to chew on and think about. And I think this an index of this kind also, we have so many indices where pretty much all the time Western European and American countries are always at the top. They are the exemplars for everything. So it is important to find and craft and defend a well-crafted index that shows that, well, there are other things, important issues that are being hidden in the construction of these indices, which should be foregrounded. And so I think you've done a great job of that. I would leave you with the two more, at least one more thing to think about, which is your material footprint. Ideally, we want to be in a world where we are 100% closed loop economy, 100% recycling. Right? Then the material footprint, in that sense, also has to. Right now, your material footprint does not account for any recycling by and large, right? So that, again, once you shouldn't put too many bells and whistles onto a simply defined index. It should just serve its purpose, and then the rest of it should be developed in other issues. So I think it's better if you stop right there. And that was one, and the other was, of course, with income you connect it to a CO2 emissions, and maybe that will change in the future. And of course, CO2 emissions come from consumption, but they also come from manufacturing. So if I put my cynic's hat on, I would say, all your top 20 EHDI countries are those that are very well endowed with, environmental and ecological resources, and don't have too much manufacturing, right?
Yeah, but now we use the consumption-based CO2, so that is, I think, broadly taken care of. But I think we agree that they might have some endowment, as Chirag was telling, geothermal for Costa Rica, and that in that case they don't need to use many fossil fuels for general purpose, power production.
I think the index as it stands is very well, and I think it should come out and it should be used further. So that's what I would like to thank you too for a wonderful talk and a very insightful talk. And well, do you want to make any last comments, and then we will probably close this?
Nothing from my end, Chirag.
Just thank you for the invitation to speak. It was the questions were very thought provoking, so given us a lot to think about as well. Thanks to everyone that asked questions and was here.
Thank you, Chirag and Saumajit, and thank you, audience. And this was a wonderful session, and we hope we will have more in the future. Thank you. Goodbye.
Bye.
Thanks. Bye.